Students, these are the video explanation problems for the Unit 2 study guide. We're starting here on page number 4. This is page number 4, problem 2. Page number 4, problem 2. The instructions say we're going to hug and distribute. We're going to collect like terms, solve. We're going to plug in the value for it, the variable, to complete the check. So problem number 2. We're going to start by hugging our outside, which is -2, and draw distributive lines. And then over here, circling the -3 and drawing your distributive lines. I'd like you to hug and distribute. Now do your second line. -2 times 12. Don't forget to keep that variable. Negative times a negative makes a positive, 8. Then we bring down the 4. Negative times a negative makes a positive, so it's positive 12. Negative times a negative makes a positive. Plus 3 times 11 is 33n. Now before you start moving rooms here, you need to clean up the rooms, which is the collect like terms. So we need to collect like terms first. There's only on the left you can collect. So our next line reads -24n plus 12 equals 12 plus 33n. Now we can start clearing here. We end up with -24n equals 33n. I'm going to go ahead and I'm going to add 24n here, add 24n. -24n plus 24n is 0 equals 57n. The only value of n here, 57 times what equals 0, is n equals 0. That is the only correct value of n to make that a true equation. Problem number 4. We're going to use intercepts or graph y equals mx plus b to solve. We're going to do both here and take a look. First we're going to do y equals mx plus b. So to do that, I'm going to subtract the x, and I get y equals -x plus 0. That's one way to do this. So right underneath that, I'm going to write y equals mx plus b. And from here we're going to solve. Our b is the y-intercept. This is y, this is x. Our b is 0, so the line crosses the y-axis, because that's the y-intercept, at 0. And then our slope, there's a negative sign there, so technically that's -1/1. So from that point, the intercept, we rise 1. Because it's negative, we have to go left 1, or we could drop 1 and go over 1 to the right this way. Either way, we get the same line. Now another way we could have used this is using intercepts. This would be the intercept method. X plus y equals 0. 0 blank, blank 0. So if we put a 0, in the x, y is 0. And here, this is 0. This isn't going to make a lot of sense because we end up with both of them at the origin, both of the intercepts at the origin. So when both the intercepts at the origin, you're actually forced to do y equals mx plus b in order to solve. Says sweep the given angles, label the diagram, so we need to sweep the given angles, label the diagram with the given information, find everything possible. Now pay attention to these instructions, because in the instructions it's going to tell you to find something specific. For example, this problem number 5. However, my instructions right above it says find everything, which I'd like you to do, and then you just identify that particular specific question. So I'm going to do number 5 here. We're going to start by marking our given information. I'm going to do this in different colors so it's easy to track. We're told that QLM is 46. The measure of angle QLM is 46. So we start at Q, trace, L, M, trace and sweep. That is 46 degrees. Trace and sweep. Picking up a different color. KLM is 8x minus 2. KLM. Pencil at K, go to L, go to M, trace and sweep. Notice that's the whole angle is 8x minus 2. And then we have this angle, KLQ, is 4x minus 4. So KLQ, trace and sweep, that is 4x minus 4. Now when you do these problems, it's much better to think in terms of things before you think in terms of numbers and algebra. It's very important you just don't slam numbers together here. Colors are what's very helpful. Look at the colors. Just forget all the numbers. Just look at the colors. If you look very closely, there's no bisector here. So right there's no bisector, so you're not going to do something equals to something. If there's no bisector, you can't use something straight up equal to something. So we're eliminating that equation. So what we could probably use, since we have adjacent angles, we could probably use this equation. Something plus something equals a bigger something. Looking at the colors, you can see that the smaller purple angle plus the smaller blue angle equals the larger green angle. Or, if I use the actual letters, angle KLQ plus angle QLM plus this angle equals the larger green angle KLM. So look to things before you look to numbers. Angle KLM. It's very important. You think about things, angles, before you think about numbers. You establish the relationship of things before you start just plugging numbers in and randomly throwing equations together. Now that you establish the relationship between things, now we can do circle, plug, chug. So here we circle KLQ, and we come up here and we see that KLQ equals 4x minus 4 plus QLM, circle. Come over here, QLM is this angle. So we circle equals the whole angle KLM. So here's KLM, the whole thing, which we are told equals 8x minus 2. Now, we can collect like terms and solve. So there's 4x still, nothing to collect it with. Minus 4 plus 46 is plus 42, equals 8x minus 2. Here I'm going to subtract 4x, cancel, end up with 42 equals 4x minus 2. Here I'm going to plus 2 both sides, and I equal 44 equals 4x, divide by 4, and of course we get x equals 11. Now, don't get all happy because x equals 11 is only the variable. So let's see what else we can now do with this variable. Let me erase all this chicken scratch here. Only one of the angles we were given, and that was QLM. QLM, we were told, was 46. So now we can do the purple angle. The purple angle is going to be 4x minus 4. So 4x, which is 11, minus 4, that's 44 minus 4. That's going to equal 40. So this angle here equals 40. Now the green angle, which we know is KLM, which is the whole thing, KLM. Let's check that. It should be, if you add 40 and 46, it should be 86. Let's check. 8 times x, which is 11, minus 2. That's 88 minus 2 equals 86. Let's put this up here. Now here's your check and see, does this make sense? 44 plus 46 does add up to 86. Check. When you plug everything in, it should fit exactly. It is extremely important that you use colors and properly sweep these angles. I highly recommend you use colors for problems 6, 7, and 8 to help you with this problem. It says, sweep the given angles, determine if the relationship is congruent or supplementary. Set up an equation to solve for x, find all possible angles. Well, congruent or supplementary. Let's actually make a list here. Congruent, put in the margin. Congruent situations, and then supplementary situations. Remember, supplementary means to add up to 180. Congruent situations. The easiest things you should watch out for congruent is first and foremost vertical angles. Vertical angles are automatically congruent. So I'm just going to write vertical angles. That's one. There's 3 more. 1, 2, 3. Those 3 more angles all have to deal with parallel lines. So we're going to draw a bunch of parallel lines there. Parallel lines, sweep it. Parallel lines, sweep it. Parallel lines, sweep it. Put the little arrow feathers to represent parallel. Now there's 3 more. When lines are parallel, what else is congruent? First one would be the alternate interior, better known in my class as armpits of the Z. So alternate interior angles. When lines are parallel, alternate interiors are congruent, better known as armpits of the Z. Next would be alternate exterior. That would be on opposite sides of that transversal, or we call it the stir stick, but outside of the lines. That would be alternate exterior angles. Alternate interior angles are congruent when lines are parallel. Alternate exterior angles are congruent when lines are parallel. And the fourth sample are corresponding angles. One's in, one's out, same side of the stir stick. Those are called corresponding angles. Those are all congruent. So we have 4 examples, 1, 2, 3, 4, where angles are congruent. Now, supplementary, we only have 2 examples. The first one is a basic linear pair. That's where 2 angles share a spine, make a line. They share a straight spine and they make a line. If you sweep that, they're back to back, share a spine, make a line. They are supplementary. They add up to 180. The second scenario is also with parallel lines, so we're going to draw a set of parallel lines here. And in this case, if they are what's called consecutive interior, they're between the lines on the same side. These green angles right here, between the lines, same side, those are called, they add up to 180 as well. Those are called consecutive interior angles. Now, these angles are summarized in your geometry reference book, Unit 2. You might want to take a look. Unit 2, this is your geometry reference book. Highly recommend you take a very close look at these 2 pages. What I just summarized is found right here on this page. Okay, going back to our sample problem 9. So step number 1 says to sweep the given angles and then determine the relationship. So we're going to sweep the 2 given angles, this angle here and this angle here. Now look very carefully down this list and ask yourself, notice that we do have parallel lines. Notice the little arrow feathers, so they are parallel. And you look carefully, which one does it match with? And if you look very carefully, these 2 angles here match corresponding angles. One's in, one's out, same side. One's in, one's out, same side of the stir stick. That's our stir stick right there. Now, given that information, we know that these 2 angles here are congruent, not supplementary. They are congruent. So we're going to set up our equation here. So we know here that angle is congruent to angle. So therefore 20x equals 19x plus 4. Now the algebra is quite easy here. Once you determine whether you're adding up to 180 or whether or not they're equal, the algebra can be quite easy. And we get x equals 4. Don't get all happy. Notice the words all possible angles. So now we have to take that x and we're going to plug it in here. 20 times 4 is 80. 19 times 4 is 76 plus 4, that this is 80, which makes sense. Those are corresponding angles. Now we're going to find every other possible angle. Let's start with vertical angles. Angles that are the cat whisker angles. So if this is 80, go right across from it, straight lines. Those are congruent, that's 80. This is 80, notice the straight lines. This is 80 as well. Those are called the vertical angles. Now right here, we're going to sweep. That is a linear pair. That adds up to 180. These 2 angles, they are called a linear pair. They share a spine, make a line. So if this is 80, that means this squiggle here must therefore be 100 degrees. Which means this squiggle on this side, the whole thing, 100 degrees. Which means this squiggle here, 100 degrees, and this one, 100 degrees. Whoops, watch out, look what we got here. We now also have another set of vertical angles, 100 degrees. What else do we have? We have here armpits of the Z. So that means if this is 80, right here, this must also be 80 degrees. And here's another armpits of the Z, so it's easy to see. Armpits of the Z going this way. That means this squiggle right here is also 100 degrees. Now we have found every possible angle here. Now be very careful, this angle right here, the yellow and the pink, we do not have sufficient information to get those. We don't know that there's a bisector, we're not given any other relationship. So finding all possible angles does not necessarily mean every angle is possible. It just means find what you can find using this list in your margin. That's number 9. Now we're going to do 13. It says, find the other endpoint of the line segment given an endpoint and a midpoint. Okay, so let's see what we have going on here. We have an endpoint of -4, 1. I'm going to do a little baby sketch here because it's easy to understand this better if you do a little baby sketch. -4, 1. So over 4, down 1 is going to be around here somewhere. -4, -1. Let's make this really big so it's easy to see. And I'm going to use different colors. So this is an endpoint here. I'm going to use blue for this. That's an endpoint. -4. So left 4, down 1. There's one endpoint. -4, -1. And then we have a midpoint of -2, 5. I'm going to make that green. -2, +5. That's going to be up here somewhere. That's a midpoint. -2, +5. So we're asking to find the other endpoint. So if we're going this way, that means our other endpoint has to be somewhere over here. We don't know what it is. So I'm going to call that purple. We're just going to call that XY. We don't know what it is, so I'm going to put a question mark there. I'm going to bring the segment down here so it's easy to see. So we have our endpoint -4, -1. We have our midpoint -2, 5. And then we have our other endpoint, and we don't know either of these. So let's see what we can do here, what we do know. If this is a midpoint, step 1, it's really important that you at least do this. Hatch mark, hatch mark. Why? Because of that word midpoint. It means it's in the middle. Step 2, I'm going to circle this X and circle this X. A little bracket, I'm going to ask myself what the distance is between -4 and -2. And it's going to be 2 units. So that means the distance from this -2 to whatever this is right here must also be 2 units away. And notice I'm going up positive, so -2 plus 2 is going to put me at 0. And then going this way, I'm going to box my Y's and go this way, -1 to +5. I'm going to have 6 units here. -1 to 0 is 1, plus 5 is 6. So from here to here must also be 6 units. So 5 plus 6 is 11. So if this was accurately drawn, our correct answer here for our xy is going to be 0, 11. Now, here's the check. I take my two endpoints, -4, -1, and my other new endpoint, and I do 0, 11. This is my check. Now, the midpoint formula, the template looks like this. You add, divide by 2. You add, divide by 2. The circle, I'm going to add the x's, -4 plus 0. And let's try -1 and 11. -4 plus 0 is -4 divided by 2 is going to give us our midpoint here is going to be -2. -1 plus 11 is 10. See, this is going to be -4 over 2. This is going to be 10 over 2, which is 5. Check. Notice it checks out. Number 15. It says, find the distance between each pair of points. Give your answer in simplified radical form. So we're going to find our two endpoints here. So this point right here, 1, 2, 3, 4, 5. I am over 5 units. And 1, 2, 3, 4, 5. I am down 5 units. So that point is -5, 5. Over here, I am over 1, 2, 3, 4, 5. I'm over 5 units, and I'm up 1, 2. 2 units. So there's my two coordinates. Now I make my distance equation template. Distance equals giant square root. Subtract the x's squared. Subtract the y's squared. That's your template. Now we're going to do circle box, plug, chug. So I circle my x's. I'm always going to move left to right. So I have -5 minus 5. Box, box. And I'm going to end up with -5 minus 2. Bring this down. -5 minus 5 is -10 squared. -5 minus 2 is going to be -7 squared. -10 times -10 is positive 100 plus -7 times -7 is 49. So I'm going to do square root of 149. And then you see if you can't factor it. Well, it's not even, so we can't use 2. We're going to check to see if we can use 3. 1 plus 4 plus 9 equals 14. 14 is not divisible by 3, so we can't do divisible by 3. So it's not divisible by 2. It's not divisible by 3. Doesn't end in 5 or 0. It's not divisible by 5. 7 goes into 14, but 7 doesn't go into 9, so it's not divisible by 9. It is a prime number. So our final answer is going to be square root of 149. That is a prime number. If it wasn't a prime number, you would factor and pull out your dates. 17 and 19. We said, write a slope-intercept form of an equation of the line described. So right above slope-intercept, actually write your equation. Y equals mx plus b. We want it in that form. So let's see what we have here. We want a line that goes through this point, negative 2, 1, but is parallel to this line. So step number 1, I'm going to figure out what the slope is. Here we have y equals mx plus b. And we see our slope here is negative 3. Well, we want it to be parallel, so the parallel slope is where slope equals slope. So our desired slope, or our wanted slope, I'm just going to write desired slope, is also negative 3. So our desired slope is negative 3, and we want it to go through this point right there. So we have our slope, and y equals mx plus b. We're now missing the b, so let's write this in. Y equals mx plus b. We have the m. The m we want has to be negative 3, so that's negative 3. Now we're going to use this x and this y to solve for the b. So our x is going to be negative 2 plus b, and our y is going to be positive 1 in this case. So we're going to solve for the b here. So 1's here. Negative 3 times negative 2 is positive 6 plus b. We're going to minus 6 both sides, so our b is going to equal negative 5. So our final equation is going to be, I'll do this in hot pink. We want it to go through that point and parallel to this line. Y equals mx plus b. The final equation is y equals negative 3x minus 5. That is your final answer there. Last problem. Here we want a line that goes through a point, but that is perpendicular to this line. So first we find the current slope, y equals mx plus b. Our current slope, the current given slope, is negative 1/2. Now for perpendicular, we know that slope times slope has to equal negative 1. Our given slope is negative 1/2. So we have an unknown slope times negative 1/2 equals still negative 1. So the question is, what is that unknown slope? And in this case, the only thing, first we know it has to be positive, because a double negative would switch the sign there. But we want it to be 1, so the desired slope to be perpendicular has to be positive 2/1. That's the desired slope. So we have our desired slope. Now we want it to go through this point, 3, 2. So we're going to plug in y equals mx plus b. And our x is going to be 3 and our y is 2. So we plug in here. Y is going to be 2 equals our desired slope, which is 2/1 positive. And then this is going to be 3 here for x, plus our unknown b, which we're trying to find. We solve. This is 2. 2/1 times 3 is simply 2 times 3, which is 6, plus b. You minus 6 both sides, and we get b equals negative 4. So our equation, y equals mx plus b. We end up with y equals our slope, our desired slope is 2 over 1 x. Our b is -4. Now you go back and complete all the unfinished problems and check your answers. When you correct something, make sure you write a note for everything that is incorrect. Show all your work.